Welcome. In this video, we'll be finding the area of a kite, part 3. Let's take a look at our example. Example. Find the area of kite ABCD given that BE is equal to 4 centimeters, AB is equal to 5 centimeters, and ED is equal to 10 centimeters. Let's take a look at what we're given. We know that the length BE is equal to 4 centimeters, and BE is equal to this segment over here. So that is simply 4 centimeters. We're also given that AB is equal to 5 centimeters. So AB is this other segment over here, and that is 5 centimeters. And lastly, we're given that ED is equal to 10 centimeters. So this other segment over here is equal to 10 centimeters. Now notice that we need to find the area of kite ABCD. So the formula for the area is equal to 1/2 times diagonal 1 times diagonal 2. And in this case, we need to figure out what are the values for the diagonals. Well, notice that one of the diagonals is just the addition of these two segments. So by the segment addition postulate, we can say that BD is equal to 14 centimeters, since we can add 4 centimeters plus 10 centimeters. So let's go ahead and say that. So we have BD is equal to 14 centimeters. And now we need the other diagonal, which is AC. So that's the unknown for now. And we need to figure out what is the actual length of that segment. Okay, since we have these pieces of information here, we can actually remember that the diagonals cross each other at a 90-degree angle. So here, we're going to be calling this little segment x, and we're going to use Pythagorean Theorem to solve for x, and then we're going to double that so we can get the entire length of the diagonal. Okay, notice here then that the side across from your 90-degree angle is 5 centimeters. That's your hypotenuse. So we're going to say that that's equal to your C in Pythagorean theorem. Now, we can say that this is one of the legs, and the other leg is going to be your x. So using Pythagorean theorem, we have a squared plus b squared is equal to c squared. And in this case, we're going to have 4 centimeters squared, or quantity square, plus x squared is equal to 5 centimeters quantity square. Now 4 square is 16, centimeter square is centimeter square, plus x squared, and that should be equal to 5 square, which is 25, and centimeter square is equal to centimeter square. Let's go ahead and solve for x. So let's subtract 16 centimeter square from both sides of the equation here. By doing so, we're going to get that this is 0. So we have 0 plus x squared is just x squared. And that is equal to 25 minus 16, which is 9. And we keep the units of centimeter square. Now, in order to solve for x, we need to get rid of the square. So let's go ahead and take the square root on both sides of the equation. So we have the square root of x squared is simply x. And that is equal to plus or minus the square root of 9, which is 3. And the square root of centimeter square, which is centimeter. Since we're dealing with lengths, we can disregard the negative, and we can just say that we're going to choose x to be the positive value of 3 centimeters. So this x value is equal to 3 centimeters. What does that mean? That means that segment AE is equal to 3 centimeters, and we can say then that AC is twice as much as that. So we can say AC is equal to 2 times 3 centimeters, or in other words, AC is equal to 6 centimeters. Okay, so we can say that indeed AC is equal to 6 centimeters. Notice that we now have both values for the diagonals. So we can just apply our area formula, and we can say area is equal to 1/2 times one of the diagonals, which is 6 centimeters, times the other diagonal, which is 14 centimeters. Okay, so half of 6, it's simply 3. So we have 3 centimeters times 14 centimeters. And 3 times 14 is 42. So we can say the area is 42. And centimeters times centimeters is centimeter squared. Therefore, we can conclude by saying that the area of kite ABCD is 42 square centimeters. And notice that's how we can find the area of a kite. Thank you for watching and have a wonderful day.